In this video, we are going to learn about series. This is the topic outline for series. The first one, we will do review on the definition of progression and series, infinite series. Then, we will learn about convergence and divergence tests. The third one is about power series. And the last one is Taylor's and Maclaurin series. This is the learning objective. So at the end of this chapter, you should be able to define the convergence and divergence of an infinite series of real numbers, determine the convergence and divergence of geometric series of real numbers, and then you should know how to use convergent, divergent, integral, and ratio tests to determine the convergence or divergence of series. And then you should know how to represent function in terms of series, approximate values using series expansion of function, and the last one is using Taylor's and Maclaurin series to obtain series expansion of functions and to approximate values. First one is the definition of progression and series. So a progression is a set of numbers given that ai, where I is equals to 1 up to infinity. So if we expand this, you will obtain, since I start from 1, so it will be a1, a2 up to an up to a infinity, which are arranged obeying a certain rule to get every element in the set, where a1 is the first term, a2 is the second term, and an is the nth term. So there are two types of progression. The first one is finite, given that finite progression if the element of the sequence ends at certain number. For example, here we have a progression of 1, 3, 5, 7, 9, and 11. So this is a finite progression because the sequence ends at 11. The second type of progression is infinite progression, given that the number of elements is unbounded. So we can see here, for this progression, start with 1/3, 1/6, 1 over 12, 1 over 24, up to different number. So meaning that this sequence doesn't stop. Okay, so we call it as infinite progression. Okay, meanwhile for the series is the sum of the terms in progression where a1 plus a2 plus a3 up to an is called series. So you can see between these two terms, okay, we have addition. Okay, so that what makes different with progression. Meanwhile, progression is a list of terms. Okay, given that a1, a2, a3 is the progression. But if addition, it is called series. Same as progression, we have two types, given that the first type of series is finite series, where the sum of the term ends after a few terms. For example, 1 plus 3 plus 5 plus 7 plus 9 plus 11. So we stop at 11. Same goes for the second example. Here we end at 20. Okay, the second type of series is infinite series, where the sum of the series does not end. So here is the first example of the infinite series, 1/3 plus 1 over 6 plus 1 over 12 plus 1 over 24 plus and so on. Okay, this is also the second example of infinite series. For progression and series, there are two types, okay, which are arithmetic progression and series, and the second one is geometric progression and series. So arithmetic progression is given as this one, 1, 4, 7, 10, 13. So this is progression. So in order to get the second term, okay, we need to add a value, a certain value to get the next term. So for example here, this progression, we need to add 3 to get the second term. So 1 plus 3, we will get 4, and then 4 plus 3, we get 7, 7 plus 3 equals to 10, and then 10 plus 3 will be 13. Same goes for the second example, 9, 1, negative 7, negative 15. So the value that we need to add is just that we take the second term minus with the first term. So 1 minus 9 would be negative 8, meaning that we have to add negative 8 to get the next term. So 9 minus 8 will be 1, 1 minus 8 will be negative 7, and so on. And this part here shows the series, meaning that the series of this progression 1 plus 4 plus 7 plus 10 plus 13 will be 35. And the summation of this will be 9 plus 1 plus negative 7 plus negative 15, which is negative 12. Same goes for the next example. Okay, so this is called as arithmetic progression, where we will do addition to get the next term. The next type of progression and series, we call it as geometric progression, where to get the next term, we need to multiply with a value. So in order to get the ratio of this, we will have to divide the second term with the first term. For example here, to get the second term, we need to multiply with 2. Because this can be, obviously we can know that this, when we multiply 2 with 2, we get 4, 4 times 2 we get 8, 8 times 2 we get 16, and so on. Meanwhile, for this case, we cannot obviously got the ratio of this. So what we can do is that we divide the second term with the first term. So we get negative 3 over 9 is negative 1/3, meaning that to get the next term here, we need to multiply 9 with negative 1/3. So the second term would be negative 3, the third term would be negative 3 times with negative 1/3, which is equals to 1, and so on. Same goes with the next example. And for this column, this is the series of the geometric progression. So meaning that when you add this 2 plus 4 plus 8 up until plus 32, you will get 62. So that is the difference between arithmetic and geometric. So the formula of the geometric progression, okay, in order to find the nth term of geometric sequence. So this is the formula. Given that the formula is a sub n equals to a1 times with r to the power of n minus 1. Given that a1 is the first term, r is the common ratio, where to get the common ratio is we need to find the second term divided by the first term, or the third term divided by the second term. Okay, so and n is the number of terms. For example, we want to find the third term of a geometric sequence. So it will be a3 equals to a1 multiplied with r to the power of 3 minus 1. So r is obtained from the division of second term divided by the first term. Next is the summation of n terms of geometric sequence. So for the geometric progression formula, it will be Sn equals to a1 times with r to the power of n minus 1 divided by r minus 1. So this formula is for r greater than 1. But if our common ratio is less than 1, so we will use this formula. Given that Sn equals to a1 or times with 1 minus r to the power of n divided by 1 minus r. So that is the formula for the geometric progression. Then we proceed with infinite series. So here, given that this is the infinite arithmetic, where arithmetic means that in order to get the next term, we have to add a certain value. So here example is that 1 plus 3, we get the second term which is 4, 4 plus 3 we get 7, and so on. So for infinite arithmetic, there will be no summation. Okay. Meanwhile, for the finite arithmetic, so to get the second term here, it will be 3 plus 4, 7 plus 4, which is 11, and so on. And at the end, we get at the sequence, for this sequence, the last term is 51. So since we have the final term, so it is called as finite arithmetic. So for this case, for this type, the formula of the sum of series would be n over 2 times with a1 plus an. Okay, and for finite geometric, it will be Sn equals to a1 times with Rn minus 1 over R minus 1. And for infinite geometric, where there is no n of this series, of this sequence, so there will be no summation. Okay, given that for this case is when R is greater than 1 or equals to 1 and R less than equals to negative 1. So if we found that R is greater or less than negative 1, okay, and R greater than 1, so there is no summation formula. But for infinite geometric, if R is less than equals to 1 or R less than equals to negative 1, so the formula of the summation would be equals to A1 over 1 minus R.